Okay, we're going to go ahead and get started. Again, thank you everybody for joining us. My name is Josh Parent, as I said earlier, for those of you that were online. I run Potter's training facility and training program. Um, Webinar Wednesday. Today, we're going to be talking about fire safety and multifamily HVAC, understanding ceiling radiation dampers. With us are Brent Davis and Taylor Cockrum. These are our CNS regional sales managers, experts in their field. I'm expecting a wonderful presentation today. A few quick housekeeping items before we start. If you would like a PDH credit for the present or spending time with us on the presentation, please put your name in the chat towards the end. We'll make sure you get those. Beyond that, we will have a gift card giveaway at the end at random. Please stay tuned for that. And with that, let me hand it over to Brent and Taylor. Gentlemen.
Thanks, Josh. Appreciate it. So folks, as Josh said, we appreciate you guys tuning in today and listen to what we have to say about ceiling radiation dampers, the applications, some of the regulations and things like that that go along with it. As Taylor and I co-present the material and the content ahead of us, if there's any questions, either feel free to raise your hand or send something in the chat. I do have Kelsey helping us out as a moderator, and I think Josh will also still be engaged in the presentation. And so we'd like to get those questions out and do it in real time. So don't feel bad about interrupting us or anything like that. It's it's not as scripted as you might think. So we just kind of want to present the content in more of a conversational type situation. And with that, we'll just go forward. Again, I'm Brent Davis. I handle the eastern side of the United States as a regional sales manager for CNS Air Products, and Taylor Cockrum, he handles the western side. So Taylor, go ahead and introduce yourself.
Hey everybody, Taylor Cockrum. I'm the Western Regional for CNS. I know some of you guys know me from before Brent came along, and I used to hold the whole territory, the entire country. So I've been coast to coast, and I kind of have a pretty good idea of the regional specialties, if you will, of all the different multifamily construction that goes along from coast to coast. So yeah, I'm here to hopefully give you guys some new knowledge. And like Brent said, if there's any questions at all, feel free to interrupt us. We are here to really make this a conversation more than just us having a monologue moment. So with that being said, we'll jump straight in. So obviously we talked a little bit in the pre-presentation about what we're going to be talking about today, but mostly when it comes to multifamily, the focus of CNS Air Products is the ceiling radiation damper. This is going to be the bread and butter for all of our multifamily construction. It's a required thing by code, and we'll jump into the specifics here, in just a second. But really, there are other products that are involved in multifamily, but most of what we're going to be talking about today is the ceiling radiation damper. A lot of that is driven by code. So this goes back years and years ago, before UL decided to start testing ceiling radiation dampers out there in the market. The California State Fire Marshal actually was the first entity in the U.S. to test for a radiation damper where you're penetrating through the ceiling. So just a little bit of history before we get into the actual code requirements, but that's where a lot of this started was, back in the 70s and 80s, before ceiling radiation dampers were really a thing. People wanted to go straight through the ceiling deck with their penetrations rather than, going through, an elevator shaft or, some sort of drop ceiling. There's a number of different ways to go about it that, costs a lot of extra money. And it's not nearly as simple when it comes to installation. So with that being said, the fire safety code requirements, the IBC, and a couple other NFPA are all required, in the code to have ceiling radiation dampers to protect from any kind of penetration points to make sure that that fire resistance rating is still applicable once you actually go through the ceiling deck. So CRDs are basically there to make sure that the radiated heat from the space below, in the case of a fire, actually doesn't self-combust the truss space above. So that's why radiation dampers are installed in every single building when it comes to a multifamily construction. So do you have anything to add here, Brent?
Yeah, just, as we talk about the fire safety codes and the requirements for these devices, it really is a life safety device. We get caught up into the building materials side of it, the HVAC component side of it, it's part of the ventilation system. But in reality, a CRD would classify as a life safety device. So, having these different ratings and certifications behind the product does mean something, either in the way of quality of having to pass certain criteria to obtain those ratings or those certifications, which just sort of leads back to the, I guess kind of the focus on quality for the product itself. At the end of the day, we need to make sure that these things work, that they work in accordance with, how the certifications, how the ratings are written, and they're that way for a reason. And again, it just ties back to life safety. So every now and then, that might be part of our value proposition that we're not focusing on or maybe mentioning, when we're talking to our customers, contractors, certainly the consulting engineers, the designers, and all that. That's there's some emphasis on the importance of them being applied correctly and with the correct ratings behind them. So that's all I got.
Okay. So kind of understanding what is required for ceiling radiation dampers. So anytime you penetrate through the ceiling space, where you're doing a supply or a return, you have to have a ceiling radiation damper behind that opening to protect the space above. And this picture up at the top has a pretty good view of what a ceiling radiation damper installation looks like up into a truss space. The most basic and standard installation when it comes to a ceiling radiation damper is to have this ceiling radiation damper in the opening. You have boot rails and sides attached to what we call a plaster ground. People call it a plaster flange. They call it a number of different things out there in the field. But those boot rails hold up the ceiling radiation damper and are screwed into the trusses. So that supports the ceiling radiation damper. And depending on whether you're installing it over the unit or into a grill application, that grill or the angles around that ductwork would sandwich that ceiling radiation damper to create a seal between the sheetrock and the space above. So that way that fire resistance rating is actually fully realized rather than just an open space up there in the opening, which we've gone back and tested with UL a lot over the years, and we've actually tested a radiation damper test where you're putting a floor ceiling assembly up over a furnace with no damper in it, so just an opening. And I think the test lasted 40 minutes before we called it. So ceiling radiation dampers add, I don't know, something like a 40% additional lifespan. So emergency vehicles can come, fire department can come, put the fire out, let people have additional time to get out of the building in the case of a fire. So they are important. Just circling back here on where they're required. I kind of have mentioned it a few times, but unit to unit separation, unit to common, so common areas in the bedrooms, in the bathrooms, pretty much any opening that you have in an apartment complex where you're exposing the wood truss construction in between floors or up at the roof, then that's where ceiling radiation dampers are required. A couple things about the rated assembly integrity is that wood truss ceiling radiation dampers are only listed for 1 hour. So for, I would say 95% of all apartment jobs that are built in the US that are wood construction, they're all going to be a 1 hour rating. So anything that you see that's above 1 hour is typically a non-combustible ceiling space, like a T-bar ceiling, where the radiated heat will eventually do some damage to the space above, but it won't be quite as critical as that 1 hour you have for wood truss, where that wood construction starts to self-combust at certain temperature ranges, even if fire actually isn't up into the ceiling space. Brent, you got anything to add on this one before we move on?
No, not really. Just, the CRD preserving the truss space from, certainly auto ignition is one of the factors that we're trying to mitigate there. If wood gets to a certain temperature, it will auto ignite. So, having that damper in place to help mitigate or knock some of that heat off is what helps to preserve the truss for that 1 hour, that golden hour that we're talking about. Obviously, to help people, escape the structure or, evacuate the building and get first responders on the scene.
So when it comes to wood truss, like I mentioned before, is the majority of construction when it comes to apartment complexes around the U.S. So most of the multifamily construction, especially new construction that you see, is this, type of construction. And they really present some distinct challenges when it comes to fire protection. Wood is fairly flammable, so as soon as someone starts to fry some fish or some chicken in their kitchen and fire spreads, I mean, it can spread very quickly if the fire protection systems aren't engaged. And that's a critical part of all these apartment complexes is the ceiling radiation damper. Not just the sprinkler system, but protecting the truss space and the ductwork from that fire is a critical part of the building integrity. So vulnerabilities in wood truss systems, they obviously have some expansive concealed spaces. So every truss system in between floors or up at the ceiling has a lot of open, expansive space for fire to really spread and grow. And that's, something that all fire protection systems have a real challenge controlling sometimes when it comes to wood constructed buildings. And also, with a lot of these apartment complexes, you have continuous duct runs, and fire is going to follow the path of least resistance. And when you have a continuous duct run, and if you didn't have protection attached to it, you would really be putting the building at risk without any kind of ceiling radiation damper. But with the duct runs, there's also a couple different things that I'll mention that aren't really part of the presentation, but fire dampers, fire smoke dampers are also integral in the construction of some of these buildings, especially in the common spaces, to make sure that fire doesn't spread from room to room. Were you about to say something, Brent? Sorry.
No, but I do kind of have a question, Taylor. When we and we'll get into this a little bit later in the discussion today, but the different ratings that we have out there, like CNS has L521, which is a proprietary rating to a specific truss design. When we start talking about these large attic areas and the ceiling assemblies, are there different L series ratings for those as well?
Yeah, so there's two different ratings from UL. It's the L listings, so that's floor ceiling assemblies. So anything from the first floor all the way to the floor below the ceiling. So if it's a 6-story building, you'd have floors 1 through 5 with floor ceiling assemblies, and then you also have a roof ceiling assembly. So everything that's a floor ceiling is an L listing, and everything that's a roof ceiling is a P listing. So when it comes to our proprietary listing, the L521, that would be the floor ceiling assembly, and then the P522, that's the roof ceiling assembly. So slightly different construction, a little bit more limited in the scope of what you can actually do in the truss design when it comes to the P5 or the P listings, because it's like it says in the slide here, it's a lot more expansive. There's a lot more room for that heat to spread. And you really want to make sure that the roof doesn't collapse. So there's a little bit more structure around the roof ceiling assemblies, which, just speaking of CNS specifically, the RD 521 BT, the boot style CRD that we have, that is one of those CRDs that isn't rated for the roof ceiling assemblies, but it is rated for the floor ceiling assemblies. So just kind of intricacies that you work through when it comes to all these different listings, when it comes to UL and the way that they design and test all these different floor ceiling and roof ceiling assemblies.
Great, thanks.
Yeah. Code. So when CRDs are required, we've kind of gone through some of the generalities of, hey, anytime there's a penetration in the ceiling space, you have to put a ceiling radiation damper there. But if you think about just in the scope of numbers, somewhere between 6 and 10 to 12 penetrations per apartment space is typically what you're going to see in each different unit. So these things can multiply quickly. If you have, say, a 300 unit apartment complex with 8 CRDs or 10 CRDs per apartment complex or per apartment unit, you could see up to 2,800 or 3,000 CRDs per apartment building. And especially if you're in the South, say Texas or Florida, you see these things all over the place. They happen to be two of the larger multifamily markets in the U.S., but not just the big multifamily markets, but these are everywhere. And every single market in the U.S., there's multifamily construction going on. So you can really see a lot of ceiling radiation dampers multiply based off of what you're seeing footprint wise on the multifamily apartments. And we've seen some up and downs in the multifamily market over the last couple of years. But one thing that we've never really seen as a possibility is that the multifamily market is going to shut off. It's going to be one of those things that has a lot of legs to it. And we want to make sure that we're up to date on the code and that we're ready to answer any questions when those questions get posed to us. So, but when CRDs are required, so duct penetrations, any kind of opening that you see, and then the wood frame systems, that's really where you're going to see a lot of ceiling radiation dampers. The non-combustible ceilings, you'll see a lot more fire dampers and fire smoke dampers as they're going through the walls or the fire rated floors. But with wood construction, you'll definitely see them going through the actual ceiling space and the hard deck to run their ductwork and make sure that the air is supplied through the units. How CRDs preserve their fire resistance. So this is actually the mechanism of how they operate, not just the requirement by the code, but at a certain temperature range, when fire gets started in the apartment space below, at a certain temperature, I think the average fuse link lasts till about 155 or 160 degrees. At that temperature, there's a soldered link, and you can see it kind of in this picture in the middle. That's our RD 521 BT, or the one to the right, the RD 521 NP. There's a fuse link that's holding two blades together, and as that temperature rises, the solder on the fuse link weakens, and then at a certain temperature point, the solder completely snaps, closing the blades and protecting the space above. And I actually got this question about a week or two ago. As long as the ceiling radiation damper isn't damaged, you can replace that fuse link without actually having to replace the whole ceiling radiation damper. So that's something that does come up occasionally. If a fuse link pops, you don't actually have to fully replace the ceiling radiation damper. You can just replace the fuse link as long as the blades are still operating correctly. So. But that's basically the way that a ceiling radiation damper protects the space above. And as the sizes get larger, typically in a ceiling radiation damper, so say like a 12 by 12 or a 16 by 12 over a unit in a closet, those blades will actually have some insulation on them as well to make sure that heat load into the ceiling in the truss space is as low as possible. Brandon, you have anything you want to add on that?
No, just again, we are talking about ceiling radiation dampers. We're not talking fire dampers. So these are to help reduce or mitigate the heat load going back, the radiated heat load going back into the duct system, not actual flames, right? So it doesn't do a whole lot for flame spread, but it helps out tremendously on radiated heat. And looks like we've got our technician at a T-Mobile there getting ready to put one in. That's what that looks like.
Yeah.
Steve's got a question, I think. Let's see here. I missed it.
Brent, you want me to ask the question?
Yeah, Steve, go ahead.
Oh, this is Josh.
Oh, I'm sorry, Josh.
No, you're good. Steve asked, is this also usable in extremely hot areas like California?
Yes.
Oh yeah, yeah. That's certainly, the temperature outside doesn't really have too much to do with the requirement from UL on the inside. So you could be one of the coldest markets in the U.S., like let's say Minnesota, and the fire protection requirements are still the same, in any part of the U.S. Really, the only thing that changes from market to market is, do you want an insulated or an uninsulated ceiling radiation damper? And Brent can probably talk more to the north with the uninsulated side, since a lot of my territory is more towards the insulated areas of the U.S. But the requirements are still the same. Does that answer your question?
Yeah, he said thanks. Thanks for the question, Steve.
So Brent's mentioned this a number of different times, but this is a life safety device, and they are critical for fire protection. So when a space, an apartment complex does catch fire, it's something that happens quickly, and you want to make sure that you have as much time for people to evacuate the building and enough time for first responders to get there and put the fire out before it spreads too much. We've talked about this a number of times with various customers, but as you're going through these different testing requirements, certain people, let's say a random boot manufacturer, thinks that they can just slap a ceiling radiation damper into any ceiling radiation boot that's out there. That's not necessarily the case. UL specifically tests for rated assemblies, so that's a big key phrase for us, is rated assembly. So all our CRDs are rated with the assembly, with all the different requirements in the assembly. And if you take out one critical piece, say the ceiling radiation damper, you don't know how that's going to react. And especially with different testing agencies, you don't know how strict they are when it comes to these tests. So that's why we typically push the UL side of things. Like, hey, we're fully rated with UL, we're fully listed, and we really try not to go outside the bounds too much when it comes to different testing agencies. But it's certainly something that a lot of people out there in the market have become accustomed to, is, hey, I can use this really wherever I want, and the inspector never flags me, so it really doesn't matter. But when it comes to a fire, God forbid something does happen where someone's property burns down, or even if there's a loss of life, this is where people are going to point to right off the bat. It's, hey, what happened to the fire protection system? Why didn't it limit the damage? And if someone is installing something that's not up to code, say a ceiling radiation damper that isn't designed for that particular floor ceiling assembly, then that's going to create a lot of problems with lawsuits and a lot of money and time and angst for everyone involved when it comes to these types of things. But if you have a ceiling radiation damper that's designed and tested for these specific applications, then you don't have to worry. And that's something that is really key when it comes to fire protection in any environment, but really when it comes to multifamily, this is the main point of entry when it comes to a fire happening in a building and making sure that that doesn't really spread throughout the entire complex.
Yeah, Taylor's exactly right. And the other thing on that, and so for those of you there in the meeting that know Taylor and I, you hear us harp on specifications, and you hear us really, drive the point home about UL, the different ratings, the ratings that we have, specifically the ones that are proprietary to CNS. And there's a reason we do that, because at the end of the day, there can be there's a chain of liability if something gets dramatically or goes dramatically, wrong, which hopefully it never does. But if we got contractors out there just wanting to sort of put in what they want to put in at their whim, or because it's the lowest number on bid day, those decisions can come back to haunt you at some point down the road. And a point that I'm trying to get to is, Taylor, if you don't mind, I'd like you to explain the L521 and how that was one of the first wood truss specifications that came from UL that was awarded, to our company, and how all that came about, and
Sure.
That it was one of the first. And
it wasn't just one of the first; it was the first. So, going back, and I talked a little bit about it at the beginning of the presentation, but the California State Fire Marshal, and California tends to be a state that really pushes the envelope when it comes to all kinds of regulations. And, some people gnash their teeth at that and don't really approve of it. But when it comes to fire protection, they are a leader in the U.S. As the California State Fire Marshal started listing all these different fire dampers and fire smoke dampers and all these different penetrations, ceiling radiation dampers were something that really wasn't a thing until the early 90s. And when UL really started taking off with their testing into fire dampers and fire smokes. So we had some customers back in the 90s in Southern California trying to get away from doing drop ceilings and, trying to find different ways to get penetrations, through their system to run their HVAC system. They came to USG. Actually wasn't us. It was the USG, the sheetrock manufacturer. And they said, hey, well, we want to do this. And we had a relationship with USG, and still do to this day, of, hey, we're looking to do this so we can kind of corner the market on these types of floor ceiling assemblies through UL. Would you guys like to partner up with us? And we'll give you exclusive rights to our listing. And it's not out of their goodwill. They wanted to protect themselves from their competitors too. But back in the early 90s, we went to UL, went and tested the first floor ceiling assembly with UL for wood truss construction, and got the L521 and the P522 listed as a proprietary listing. And the reason that's important is because we were the first. It speaks to a couple things. One, that we're very engaged in the code, still are today, and it's the most listed floor ceiling assembly in the U.S. So if engineers and inspectors are going to follow the code and actually enforce what's written by UL, then we are the proprietary design and the only ceiling radiation damper allowed in that particular floor ceiling assembly.
Yeah, that's the point I was wanting you to get to, Taylor, for sure, which is, the L521 is, I'll just say it most likely is the most widely adopted L spec that's out there, just because simply we were the first ones to do it, the first ones awarded. So it's been out there, it's been on the books a little bit longer. And so you're going to see L521 a lot as you're looking. But by that same token, you're going to see other L series specifications as well that our competitors also partake with. So but I just kind of wanted to highlight, the history that surrounds that L521, how that came to being, and that we were really just right at the forefront of it. And I think it's kind of important for our company's history and sort of what we bring to the market as well. So, yeah, that's all I have on that.
So sweet spots for CRDs. This kind of goes back to the types of apartment buildings that are getting built, out there in the U.S. But the low and mid-rise multifamily apartment complex is really the biggest new construction thing that we've seen. We don't really see the high-rise multifamily zones really much anymore, as people are going towards the more towards the rural side of America rather than the urban side of America. And these apartment buildings are getting, built all over the place. Obviously, there's some hotbeds for it, but there's apartment buildings being built everywhere. So, Brent, and you might be able to speak to your territory a little bit more than mine, but it seems like as people are moving out of some of the big cities like New York or LA or San Francisco, they're moving out into the suburbs, and that's where you're seeing a lot of these mid and low rise multifamily complexes.
Oh, absolutely. Yeah. Where in times past, the city centers were just, kind of the place to be. And of course, any of the high rise construction is masonry for the most part. And, really doesn't require, ceiling radiation dampers. But over the past few years, as we've increased in our urban sprawl, yeah, the more metro outlying markets have given way to just more and more people trying to find affordable housing, and a lot of it boils down to that. So when we start looking at the cost of housing right now, and it's not that mortgage rates are anywhere near the highest rates that they ever have been, but they're certainly off, the COVID level, interest rates, which everyone would love to go back to, but I just don't think it's a reality. Uh, People are trying to find value in housing, and certainly for younger folks, their first you know, foray into looking for housing as a young couple or as a young person, they're not putting down all that money for a house. So that in and of itself has helped spur the multifamily housing segment. If you listen to people and listen to some of the reports that are out there, and there's plenty of them that you can subscribe to, or get on someone's website and kind of get everyone's theories, concepts, and opinions on where the multifamily housing market's going. But generally, it's up. It can certainly it modulates throughout the year. But overall, I mean, the trend as we march towards 2030, it's generally on the upside. So there's going to be continued growth. I think there's going to be continued expansion in the multifamily housing segment. It certainly is, a great place for us to be focused. Obviously we sell a lot of product into that channel, and don't see it pulling back. And as to the type of structures that they're building, the type of multifamily housing projects, you're right, Taylor. It's that 6 story and down. It's that 5 story and down. I think we've all seen that mixed use. Residential on top, retail on the bottom. That seems to be sort of a big trend. I see that a lot here in the Sun Belt states. Specifically Florida. They do a lot of that. And the younger folks kind of, they like that. They kind of flock to that. There's restaurants on the bottom. There's shopping. There's retail and all that good stuff going on. Bars and cafes and whatnot. So there's a lot of things that are attracting that type of customer into multifamily housing, and there's just a lot of it for sure.
Yeah, and on top of that, just the ease of living in an apartment complex. You don't have to, think about maintenance. You have a pool there typically. You have a gym and common space, and there's especially for the younger generation, but even for people who might be sick of owning a home and the constant maintenance. just to add on to Brent's point about the growth in the market space and how we think it's going to continue to grow going forward. It's certainly, like he said, a good spot for us to be focused into. So ceiling membrane challenge, obviously wood construction, we've talked about it a little today about, how vulnerable they are in the case of a fire. But, it does really, go right back into the fire protection conversation we were having earlier about, these are life safety devices and we want to make sure that they're up to code so that fire doesn't spread and it's contained in a proper way. I mentioned it a little bit earlier about, the typical requirement for how many CRDs are in an apartment complex, but it really depends on the amount of penetrations and how much, airflow they're trying to move through these apartment complexes. But, like it says there, 100 unit mid-rise is typically between 400 and 800 ceiling radiation dampers. So, as you're multiplying and, especially here in Texas, but the surrounding states too, you'll see some, 400, 500 unit apartment like super complexes. So, those ceiling radiation dampers can add up quickly.
Yeah, they're it's definitely the volumetric side of what we do. I like people to pay attention, especially our customers, to the overall project. But everyone's going to focus on where the volume is, and that obviously resides with the ceiling radiation dampers. And the more versed, the better we can talk about the application of these devices. It might give us the opportunity to win more bids in the market for sure.
Yeah, this is kind of a breakdown of what the usage is in these different types of apartment complexes, and you'll see some ceiling radiation dampers in those high-rise concrete applications, but it really lives in that wood truss or mid-rise apartment complex with the multi-use. And it's a great place to start. Really focusing your efforts on who's manufacturing or who's building these buildings and who's driving those decisions. Opportunity summary, focus on that 5 to 6 story market, wood construction, new construction, and kind of take it from there. But wood frame specifically means that there's going to be ceiling radiation dampers involved, and it's just a matter of where are they getting their ceiling radiation dampers, and how can we as a company, CNS, help make things easy on them. And that's certainly something comes back to our longevity and intimacy with the code and how we've written the code, how we've designed some of these tests, help UL design some of these tests, and really the way we want to drive the market going forward, finding different requirements for contractors to make their lives easier. High rise, obviously, at the end is a different game. A lot of concrete and steel construction. You're going through elevator shafts and a lot of different types of ductwork design versus the 5 to 6 story market, where a lot of it is going through each individual apartment unit with a 3 to 5 ton unit.
Right. And Taylor, something that I get every now and then on the application side, maybe you can speak to this a little bit, is, how come we're starting to see requests for dynamic CRDs versus static? And can you give us a little color on that?
Sure. So dynamic CRDs, dynamic versus static, I should probably start there. Dynamic systems have the units running, your air systems running in the case of a fire. A static system is where you would have the unit shut off, so there's no airflow through your system. So pretty much every ceiling radiation damper out there on the market is designed and tested with a static system. So there's no airflow moving through the system. It makes it very easy to contain the heat load and make sure that things aren't collapsing earlier than they are designed to. So this goes back probably 10 or 15 years, but UL designed a test, back in 15 years ago to say, okay, we want to design a dynamic ceiling radiation damper so people can, have that application out there. The thing is, the test that UL designed was very expensive and very restrictive and hard to pass. At the time, we thought there's no way anyone can pass this because it's not the ceiling radiation damper that's the fault. It's the sheetrock and everything else that's required as you're moving all that airflow through the system. You're really putting a lot of stress on everything, and the systems would typically collapse into the furnace at around 45 or 50 minutes. 10 minutes plus shy of actually hitting that 60-minute mark that's required by code. So most ceiling radiation damper manufacturers said, you know what, we're just going to stick with the static designs. They seem to be the way that everyone is going about these, 5 to 6 story wood constructed buildings anyway. So we'll stick with that. I think it was maybe 2 or 3 years ago, the IBC changed some language and where they actually presented the requirement for dynamic ceiling radiation dampers. It actually states that there is a ceiling radiation damper that needs to be dynamic at the unit itself, which it says a dynamic ceiling radiation damper is required, or you have to put a fire stop so the unit shuts down in the case of a fire. So most contractors / engineers see that and they're like, well, the cheaper thing to do would probably be to do a dynamic radiation damper at that spot. Instead of spending money on the fire stop device for the unit. So they started requiring dynamic ceiling radiation dampers. But the kind of caveat is a lot of these designs that they're testing and constructing are actually still static systems. So there's no caveat for, oh well, there's just a dynamic ceiling radiation damper at the unit. It's you have to put a dynamic ceiling radiation damper at every opening in the entire system, and you have to change the design of the building. So there is one dynamic ceiling radiation damper out there on the market right now. But the thing about that specific design, and I'm going to get into some intricacies of the code here, but there's the L263, which is the test for all these different floor ceiling assemblies. And the damper manufacturer that decided to do this dynamic ceiling radiation damper tested it that way. So it's one floor ceiling design that's dynamically listed, but it's very restrictive. So you have to have double layer sheetrock. You have to fully insulate the ceiling radiation damper. I think it was with R11. And then you also have to have hard duct throughout the entire system. So not only does it make the ceiling radiation damper more expensive, it makes the entire system more expensive. So you would have to completely redesign the entire building to make sure that you can adhere to this one requirement in the IBC, or you could just have the unit stop in the case of a fire and save yourselves, a couple $1,000s. So it gets pretty convoluted when people are like, well, I need a ceiling radiation damper that's dynamic for this one opening, and that's not necessarily the case, because if you go back to the way UL tests everything, it goes back to, hey, this is an entire assembly, not just one damper that needs to be dynamic. So hopefully that was not too long-winded and it got the point across. But did that answer your question?
Yeah, no, that's perfect. Because we hear it called out every now and then, or sometimes our reps or our contractors out there will see these things listed or asked for, or it comes back through a design, and just understanding what it truly is, and how highly restrictive and cost and there's a lot of cost involved to it. So just being able to communicate that back to the folks is sort of important.
Yeah, and it's certainly something that we're working on. We have a couple tests in mind, and I think one's actually scheduled to go get tested to give contractors and engineers an answer for this dynamic ceiling radiation damper requirement in the IBC, but it's not really something that we're ready for right this second. But kind of going back to the beginning statement of, hey, we're here for the long term and we want to make sure that we understand the code and help drive the code. That's something that we're working on going forward. It's just not quite there yet.
Right. Well, great. Well, we are about 15 minutes out from being concluded, and I figured we would reserve the rest of this time for any questions, any a little Q&A time. If anyone has any questions, or Steve, and let's see here. So as I bring up the chat, I'm clicking on the little chat icon. Steve says, can it be added post-construction? I do have a few clients who should have this, but don't. So they've they've built a building. It probably has a requirement for CRDs by code, but they just didn't install them at construction. Taylor, I don't know. I don't know that I'm. Not that you can do a retrofit. I'm sure you can. I just think it's probably cost prohibitive. But
yeah, that would be my answer to that. Is yes, you can do it, but it's going to be expensive because you're going to have to rip the sheetrock up to create space for the ceiling radiation damper to get installed properly. Plus, you've already run all your duct work, so you're going to have to design that particular instance as well. Plus, probably new grills. So yeah, it's not a cheap thing by any means, but it's certainly something you can do. And we've seen this, not necessarily that people forgot it, but where we've had some contractors in the past install the cut corners type of CRD where it's not listed, and the building inspector required them to rip it all out. So certainly something that's happened before, but it is not a cheap thing.
yeah, I mean, I've heard those horror stories as well. There's a couple of guys up in the Northeast that they tried to get away with using a cheaper CRD, and we happen to be listed, and that inspector knew to look for CNS. There's a label on our product, and certainly we incorporate that L521 is incorporated in all of our CRDs that are wood truss certified. And the inspector knew what part number he was looking for. He knew what manufacturer he was looking for, and that's not what he found. So they had to rip out, I think it was like 300 or 400 of these things. And at the end of the day, man, that is a big hit to take. So,
yeah.
Again, sometimes there's consequences to trying to be, lowest on bid day.
Yeah.
Let's see here. Will says, so can Podorf give us something official that we can send to the contractors and inspectors in response to this? In response to the dynamic situation, Will? And you can come off mute if you want to.
Yeah, I don't know if that's an admin thing or not. I don't think
Yeah, Brent, we have the microphones turned off for this one. We'll have them on for the next one. Sorry about that.
No worries, no worries. So yeah, Will, all right, correct. So you want something from the factory that talks about the dynamic situation. I'm not sure about that. I'm thinking we could probably have something written up. I know that Taylor and I have been putting our heads together on, how do we better educate folks out in the field, and if it's a letter from the factory, then so be it. What are your thoughts on that, Taylor?
Yeah, I certainly think that that's something we can do. It doesn't have to be anything too in depth. Obviously, people are going to ask some questions, but I think just a simple question and answer type of deal we post on the website about this would probably be good enough. I'll say it's something we'll probably have to run by engineering to make sure that it's all language wise correct. But I don't see any problem in getting something like that done.
Perfect. Well, there you go, Will. Another honeydew for me. Anything else? Does anyone else have any questions? I mean, Doesn't necessarily have to be about CRDs. If you've got a question about, fire dampers, fire smokes, this particular session was dedicated for CRDs, but we're happy to talk about the broader offering that CNS has to bring to market for sure.
Yeah, and that speaking of that point, Brent, when it comes to multifamily construction, you're definitely going to see fire dampers and you're going to see louvers. So it's not just the ceiling radiation dampers that are a part of our offering. When it comes to multifamily, you're going to see, louvers, for outdoor air intake or exhaust, and you'll see, fire dampers or fire smoke dampers, depending on, how they're designing the building, in the common areas, office buildings, that sort of thing as well. So.
Absolutely. Yep.
Hey, Brent, Taylor, we have couple more things in the chat. I was going to close it out, but it's still going. So go ahead.
Yeah. I see that as well.
Looks like Will tacked on to his comment. He said also, and I heard this is in the works, something in a cease and desist type of letter, or something that we can send inspectors/contractors about competing manufacturers to educate people on the verbiage. Also can be used in L. Oh, yeah, right. So what Will's talking about is other manufacturers saying, yeah, we are L521 compliant. L5, these L specifications we've been talking about are proprietary specifications that, the folks that design these truss systems come up with, and then they have a bill of material, and in that bill of material resides the CRDs. We happen to reside in L521. There's other manufacturers that like to say, well, we're tested in accordance to the performance parameters of L521, so we'll just put that on our submittal, saying that we can test into L521, or however they say it. And Taylor says it better than I do, but it's just them saying, yeah, ours is good enough, and kind of doing a me too on it. We have certainly looked at calling certain manufacturers on the carpet for doing that, because every now and then it's pretty blatant. But to some degree, I think all manufacturers kind of engage in that. Hey, we perform in accordance to, or our rating is equal to. You just see a lot of that these days, and it's not that I would be on doing a cease and desist on someone trying to really infringe on the spirit of the specification, but sometimes it's just hard to roll out. Taylor, you got any thoughts on that?
Yeah, I think that's the tricky part about it is, we're not the enforcing agency. I think that's the problem we struggle with the most, is that the L521 is in UL's hands. So if UL isn't going to go slap anybody's hands and really call them out on, some deceiving messaging with their submittals, then we're kind of, at their mercy to an extent. I will say, like you said, Brent, with, if they're really egregious, we can probably go and do something and have their submittals pulled from their website, because UL will pull their listing. But, if a certain manufacturer is not testing with UL and they're testing with a competitor, but it's tested in accordance to UL's design, then, UL says that there's not much you can do about it, which I think, we just as a company need to find a better response than that, because we are certainly losing opportunity because we did the right thing and went down the right path, but other people are not, and they're kind of piggybacking off of our work. So, to answer your question, Will, I'm sure that, we can figure something out. I just don't know what that actually is going to look like. But I do think, to your point right there in your response, is, reaching out to the municipalities and the inspector organizations, that's the way to stop it. And to that point, Brent and I are happy to go out and talk to inspectors, happy to go out and talk to engineers. So if you can work up those kinds of opportunities for us, we're certainly happy to go and present or have conversations with all those entities.
Great. So let's see what, so Terry had a question up here. He said, is there a requirement to add a CRD to a multifamily home complex that is going through rehab? Yeah, it's got to be there, Terry. But especially if it's wood truss. If this is a wood truss rehab or refurb, uh, either they've got to use the existing if there's one there, and if not, I believe it would have to go in accordance with that kind of life safety stuff doesn't grandfather. So it's got to go with the most current, either IBC or building code that's in effect. So yeah, they would have to, if they didn't exist, they'd have to put them in.
Yeah, I'll say this just to add on to that. If they're going through and they're ripping ceiling or radiation dampers out, then they need to replace them.
Yeah.
If they're just say, repainting the walls or replacing appliances, then they're not going to have to mess with that. But as soon as they start messing with the ductwork and any kind of penetration, that's when they're going to have to replace the ceiling radiation dampers.
Right. Cool. Steve asked, are there any new technologies replacing traditional CRDs? Not that I know about. The only thing right now, Steve, that's going back and forth is this argument between dynamic and static. That's really the only thing that's sitting out there right now. There's different building methodologies, the way that they're constructing buildings to prevent having to put in a CRD, but as far as, and which is a big upfront cost to whoever owns the project, but as far as just technology now, it's real simple, and really this kind of device, it's keep it simple is kind of the way forward. We just it works great. It's basically a gravity fed system. It's going to work. There's a spring, there's some gravity, there's a link, boom. It's one of those things where we try not to overcomplicate the thing.
Yeah, and any kind of design that we would alter would require extra testing and extra charges, which means that cost gets pushed down to the customer, which we're trying to avoid. So I think that's the main reason why there's not really much quote unquote innovation behind traditional CRDs, is because the more money that we spend, the more that gets passed on to the end customer, and we want to try and make these things as affordable as possible.
Yeah. At the end of the day, it is building material. John Edmonds has his hand raised, it looks like. Is that?
Yeah, looks like that's John, you might have to type your question out in the chat.
Yeah, unfortunately, we didn't set this, like with most of our big webinars, we set it up to have everybody muted for the full presentation. So either throw it in chat or contact one of us after the presentation. We'll be happy to help you out.
Absolutely.
And with that, we are running out of time. I don't want to give Kelsey her a lot of time, but if you need PDH, if you need PDH credit for the course, please drop your name in the chat. And with that, I'm going to hand it off to Kelsey to close us out. Kelsey?
All right. Good afternoon, everybody. Thanks for tuning in to the very end. I'm Kelsey Flickinger. I'm the Marketing Associate for CNS. For those of you who would like to claim your PDH credit, again, please go ahead and identify yourselves in the chat so we can send you your certificates. And with that, thanks everybody for attending. We can't wait to see you at our next webinar. Enjoy your day.
Thank you, everybody.